These are the answers for the revision questions for 1.7 Redox. Question 1. Using the half equations below, which of the following is the balanced ionic equation for the reaction between acidified manganate 7 ions and ethane dioate ions? So if we look at the two equations here, the acidified manganate 7 ions, we have MnO4 minus plus 8H plus 5 electrons gives us Mn2 plus and 4 water, and ethane dioate C2O42 minus gives us 2 CO2 and 2 electrons. The important thing here is the electrons. So in the first equation it's 5, and the second one it's 2. So we need to multiply this one by 2 and this one by 5. So what I'm looking for is an equation where I have 16 H pluses. And if I look straight away, I can rule out B, because there's only 8, and D, because it says 40. Now, I want to also see that I have everything else balanced, so I need to have 2 of the MnO4 minus. Both of those equations have that. Both have the 16 hydrogen ions. But if we look at the first one, there's only 1 ethane dioate ion when there should be 5. So that means the answer is C. Number 2, concentrated nitric acid, HNO3, oxidizes iodide ions to form iodine. In the reaction, the nitric acid is reduced to form nitrogen monoxide. So it says, reduction and oxidation can be defined in different ways. Define oxidation in terms of electron transfer. All you have to say here is oxidation is loss of electrons. And that will get you your mark. Define reduction in terms of changes in oxidation state. So in this case, we're going to say reduction is a decrease in oxidation state. Now, define the oxidation number of nitrogen in these two compounds. Number 1 is HNO3, number 2 is NO. So in HNO3, the hydrogen's +1 and each oxygen is -2. So we've got 3 of those, -6. So overall the nitrogen has to be 5. So it's -6 + 1 is 5. And then in NO, the oxygen is -2, so nitrogen has to be +2. Just realised I left out the plus there, so it's +5 and +2. So next, the half equation for the reduction of concentrated nitric acid is shown below, with HNO3 and 3H plus 3 electrons gives you NO and 2H2O. Write a half equation for the oxidation of iodide ions to form an iodine molecule. So iodide ions, I minus, iodine is I2, so we need 2 I minus, and we're going to get 2 electrons on this side. So combine the reduction and oxidation half equations to give the overall equation. So that's looking at the one for the nitric acid and the one for the iodine. So in this one we have 2 electrons, and here we have 3 electrons. So we need to multiply this one by 2 and this one by 3. And that's going to give us an overall equation of 2HNO3 plus 6H plus 6I minus. And on the right hand side then we have 2NO and 4 waters and 3 iodine. Okay. Number 3. Chlorine forms a series of oxides, some of which are listed below. We've got chlorine monoxide, chlorine dioxide, chlorine hexoxide, and chlorine heptoxide. So you haven't seen these before really, and it's one of these questions where you're expected just to use your knowledge rather than knowing the answer straight away. So deduce the systematic name for chlorine heptoxide using the oxidation state of chlorine. So looking at this Cl2O7, we have 7 oxygens and each of them are -2, so that's -14. So each chlorine then has to be +7. So it's going to then be chlorine, and the oxidation state is 7, so you write it as Roman numerals in the brackets, and then oxide. Next it says chlorine dioxide dissolves in water to form a solution which eventually forms a mixture of chloric and hydrochloric acids. So 6Cl O2 and 3H2O gives you 5HClO3 and HCl. The chlorine atoms and chlorine dioxide undergo disproportionation in this reaction. So explain the meaning of the term disproportionation. So you have to say that it's oxidation and reduction of the same element in the same reaction, not just oxidation and reduction happening at the same time, because that's redox. So it's oxidation and reduction of the same element in the same reaction. Okay, then you're asked to calculate the oxidation state of chlorine in the reactant and in the products of this reaction and use them to confirm that the reaction is a disproportionation reaction. So, in here, in the ClO2, each oxygen is -2, so I've got 2 -2s, which is -4, so the chlorine then has to be +4. And then in the products, we have the HClO3, so we've got +1 for the hydrogen, and we have 3 -2s, which is -6, so it has to be +5. And then in HCl, it's just -1, because the hydrogen is +1. So we're going to use that in the answer. And we're going to say that in ClO2, chlorine is +4, and in HClO3, chlorine is +5, and in HCl, chlorine is -1. So you're going to get 2 marks if all the oxidation states are correct. And then your final mark here is for saying that chlorine has been oxidized from +4 to +5 and reduced from +4 to -1 in the same reaction. And that's going to get you your 3rd mark. Okay, and finally, what is the oxidation state of nitrogen in the nitrate ion NO3-? So we've got overall is -1. We have 3 oxygens, which are -2 each, which is -6. Overall it's -1, so it has to be +5.